Now, let's move to the non-deterministic finite automata, which is also known as NFA. It is used to transmit any number of state for a particular input. It can accept the null move. It means that on giving any input to the non-deterministic finite automata, it can move to or it can move to more than one state. Again, a non-deterministic finite automata is also known as NFA, or you can also say it as a NDFA. It is represented by a 5 tuple, and these tuple are same as the deterministic finite automata. Capital Q, which is a finite set of state, summation, the finite set of input symbol, transition function. Q0 is the input symbol, is the initial input is the sorry Q0 is the initial state and F is the final state. The difference between the deterministic finite automata and non-deterministic finite automata lies between its transition function. If we will see the formula of the transition function in the DFA, what we will observe that in transition function, here the transition function delta is represented by Q into summation represents only Q. It means on giving some input symbol to the state Q, it reaches to only one state that belongs to the Q. But in NFA, or you can say that NDFA, where on giving some input symbol to the given state, it can reaches to more than one state. So here the transition function is represented as Q into summation tends to 2Q, 2 to the power Q. Here the power set of 2Q has taken because in case of NDFA, from a state, transition occurs to any combination of Q state. Now let's see some facts about DFA and NFA. Every DFA is NFA, but NFA is not a DFA. If we talk about the power of the DFA and the NDFA, then both the power are same. The power of both DFA and NDFA are same because NFA can be converted to a DFA. There can be multiple final state in both NFA and DFA. We can have more than one final state in both the cases. DFA is used in lexical analysis in the compiler, while NFA is more of a theoretical concept. Now we will take the first example of the DFA. If you can see this transition diagram, this diagram is known as transition diagram. Here how many states are there? There are 3 states, Q0, Q1 and Q2. And if you are asked to draw a transition table from the given transition diagram, then how we will draw the transition table? Here this is the transition table of the example 1, and here the first column represents the number of state, and we have Q0, Q1 and Q2, and there are two input symbol 0 and 1. And from the transition diagram, what we have observed that on giving 0 to the state Q0, we reaches to Q1, and on giving 1 to the state Q0, we reaches to the state Q2. And in case of Q1, on giving 0, it reaches to Q0, and on giving 1, it reaches to Q2. And in Q2, on giving 0 and 1, it remains on the same state because there is a self loop over the Q2. Here Q0 is the initial state because a incoming arrow is there, and Q2 is the final state because it has a double circle. So let's see the transition table. In Q0, on giving 0, we reaches to Q1, and on giving 1, it reaches to Q2. In Q1, let's see the third row, Q1. In Q1, on giving 0, it reaches to Q0, and on giving 1, it reaches to Q2. And in Q2, on giving 0 and 1, in both the cases, it reaches to Q2 only. So in this way, you can easily represent a transition table from the given transition diagram, or if the transition table is given, you can easily draw a transition diagram. Let's see the explanation of the example 1. Here the first column indicates all the current state. Under column 0 and 1, the next states are shown. The first row of the transition table can be read as when the current state is Q0 and input 0. On input 0, the next state will be Q1, and on input 1, the next state will be Q2. In the second row, when the current state is Q1, on input 0, the next state will be Q0, and on input 1, the next state will be Q2. In the third row, when the current state is Q2, the next state will be Q2 because on giving 0 and 1, it remains on the same state. The arrow marked to Q0 indicates that it is the initial state, and the circle marked with the double circle indicates it as a final state. Now let's take one example of a NFA. This is the transition diagram of a NFA. Again, let's first find out the number of states. Here we have 3 number of states, Q0, Q1 and Q2, and we have 2 input symbol 0 and 1. Now let's draw the transition table. From the transition diagram, what we have observed that on in Q0, on giving 0, either it reaches to Q0 or Q1. Once again, I am explaining you. On the state Q0, on giving 0, we reaches to either Q0 or Q1, and on giving 1, it reaches to Q1. If we will take the state Q1, on giving 0 to state Q1, it reaches to Q2, and on giving 1 to the state Q1, it reaches to Q0. And in the state Q2, on giving 0 and 1, it remains on the same state. So from this example, we have observed that in NFA, on giving some input symbol, it can reaches to more than one state. So let's see the transition table. Q0 is my initial state, so it is represented by an incoming arrow. On giving 0 to Q0, it reaches to Q0 and Q1, and on giving input 1, it reaches to Q1. Let's see the third row. On Q1, when we give 0, it reaches to Q2,